So we are looking at something called the tangent ratio. If everybody can get their calculator out in front of them, and if you have an iPhone, I need you, iPhone or even a Samsung, turn it sideways for me. Okay? You'll see three buttons in a row. You'll probably see one that says TAN, SIN, and COS. You see those three? See those three? If you turn yours sideways or you see it on the calculator, those are going to be our best friends for this unit. Okay? This is called tangent. You might want to write this stuff down. This is called sine, and this is called cos or cosine is the proper name for it. Okay? So really, when we're going through this, we just call this tan, sine, and cos. Okay? Or kind of how we go through it. Here, I'll just, is that a little better in the back? Cool. So these are three things that we're going to go over. So and those buttons are going to be our best friends through this unit, okay? Now, each of these is a ratio of two different sides, okay? So whether or not we're using the hypotenuse, the opposite, or the adjacent. And right now, you might not have an idea of what I mean by that, but you will as we go further through this. So the hypotenuse, once again, is that side across from the 90-degree angle, the opposite being the side across from the angle, and then the adjacent, again, being the one right beside that angle we're looking at. So we're going to use something called the tangent ratio. So we know on our calculator, we have this button that's tan, okay? We have that button. But you're also going to get used to an acronym, called TOA. Please write this down. TOA is going to be your best friend for tangent ratio. And if I looked at hypotenuse, opposite, and adjacent, does anyone have an idea of what might we use based on TOA? Yeah? No. It's okay. Yeah. So the opposite side and what else? The adjacent, right? Because we can see it, O and A. It's okay. You actually narrowed it down, which is perfect. So we have tan standing for T, O standing for opposite, and A standing for adjacent. And the tan ratio is actually going to be tan is equal to opposite divided by adjacent. Might be something clever to write down. And right now you're like, oh my goodness, I have no clue what this means. But I promise you, as we go through this, you'll go, oh my goodness, this is super easy. So if we look at the tangent ratio and we have two different, well, basically two of the same right angle triangles, we're actually going to be able to use or find this angle measure based on knowing the side lengths of the opposite side and the adjacent side. So we're going to use that button to eventually help us get this angle based on having this side length and that side length. So having the opposite side length and the adjacent side length, we're going to be able to use that button on our calculator to help us find out what that angle is, which you've probably never been able to do before. Other than if you had two angle lengths, you would just do 180 minus one angle minus the other, getting the answer. But now we're going to be able to use it without any other angle length or any other angle measures, which is pretty cool. So the tangent of an angle, x, is equal to the length of the opposite over the adjacent, or tan x is equal to opposite or adjacent, and that's where we get that TOA. Okay, TOA being our best friend, that's a little acronym for the opposite over adjacent. So if we look at some similar right angle triangles here, we can find out some things here. So we're going to be able to find out by using TOA that tan x is equal to the opposite over the adjacent. So in this first triangle, what side is the opposite? And the x is down here, okay? What side's the opposite? Yep, 3, this being the opposite. And which side's the adjacent? 4, exactly. So in this case, we would do tan x is equal to 3 divided by 4. That being, if you did that on your calculator, you should get 0.75. Now, remember the other day we did similar triangles and we took a look at that? Similar triangles have the same ratio. So in theory, this angle, remember that similar triangles have the same angles but different side lengths? In theory, this angle or this x should have the exact same ratio of 0.75. So tan x is equal to opposite over adjacent. What's our opposite side here for that second triangle? Thank you. And what's our adjacent? 8. That means 6 divided by 8 on our calculator. So we want to do that. 0.75. So both of these are similar triangles because they have the exact same angle but different sides. All right, last one. Which sides are opposite? 12. What's our adjacent? 16. If we do that on our calculator, 0.75. So that shows us that similar triangles, based on the tan ratio, have the exact same angle. That's what we were looking at the last couple of days on 2.6 and 2.7. Some of you missed that lesson, but that's exactly what we're looking at. Is they have the exact similar triangles, have different side lengths, but they're equal proportions, but their angles are all the same. Okay? Just give you a second to write that down. Good, good, good. Okay, so it says here, calculate the tangent for the right angle triangles with the following measures. Round off your answers to 4 decimal places if necessary, okay? So what is our equation for tan? Adjacent, yeah. So we always remember that by, what's our acronym? TOA, right? So just throw that right up at the top. We always know it. So what 2 numbers am I going to divide here? 6 divided by 10. What's it equal? Sorry? 0.6, okay? So our ratio there. Okay, the next one, tan x, we know it's equal to opposite over adjacent. What is my fraction going to look like? 11 over 7. So tan x would be what? Sorry? I don't have that. No, anyone else have a different answer? I have 1.5714. So don't press the tan button, but it's just 11 divided by 7, right? Should give you that answer. Okay. 4 decimal places. It was 57142, so we just keep it at 4. Okay. So basically, we're just setting you up for where we're going next, but if you can figure out which one's the opposite and which one's the adjacent, pretty easy to figure this out, right? Okay, so for the next one, if I wanted to find tan A, so tan A is referring to what angle? No, what those are side lengths. So adjacent and no, what angle? Angle A, right? So it's right in here. So angle A is where our little x is going to go. It's all right. It will start making more sense. So that's, we're looking at, we want to find out the ratio based on this angle, which is A. So if it says tan A, it means we're referring to the angle here. Opposite and adjacent are side lengths, okay, not angles. They're side lengths. So they're the different sides. So if I was looking at angle A, what's our opposite side? 10, right? Because it's opposite of it. And what's our adjacent side? Exactly. So for this case, tan A is equal to opposite over adjacent. And tan A is equal to then 10 over 5. Tan A is equal to what? 2. 10 divided by 5 is 2. Okay? So now things are going to change slightly. We're looking now at tan B. So what angle do we need to refer everything to now? B, right? It's that simple. I think we're overthinking it a little bit. So we refer to B. So this is the angle we're looking at now. What side is our opposite? Is what? Exactly. And what side is now our adjacent? 10, right? So then our answer being 0.5, right? Okay. So now we're going to do something where we actually use that key, okay? So if you have a calculator in front of you, great. If you have your phone, turn it sideways because you'll need that big calculator there, okay? You can do me a favor. If you have it, calculators are funny. Sometimes it's one way or the other. So sometimes you're going to hit 65 tan. Other times you'll hit tan 65. It depends on your calculator. One will say error, the other will not. On your iPhone, you're going to type the number first. So you're going to hit 65, then 10. What do we get? I got 2.1445, right? So 2.1445. So try that again. Hit 65 tan. Oh, we got it? Okay, so you should get that. Does everyone get that? Did you get that on your calculator? Just you're using your calculator? Awesome. All right, so the next one, if we did it 40, 10, what would we get? 0.8390. Is that what everyone else got? 0.8390. Awesome. How about tan 50? 1.1917. Agreed? And then the last one here, 75 tan or tan 75. Sorry, could you say that one more time? 7320. Cool. Now we're going to show you how this all kind of comes into play. Okay. So it says find the following angles to the nearest degrees. And this is going to be very strange. So we have tan A is equal to 0.5774. So we've been given a ratio just like we have been in the past. So basically, this answer here is an opposite side and adjacent side divided by one another has given us this. But now we kind of sit here and go, well, what do we do with that? Because I thought the whole point of doing these ratios is that I could get the degrees of the angle. Well, that's not a degree of an angle, 0.577. That would be super, super small, right? You could barely even see it. So now we're going to use something on your calculator that's going to help us with this. Now, if I wanted to get our variable by itself, which is A, what do I have to do? So you guys are on the right track. What do I have to move? No, I think you're on the right track. So we have to move this over. Okay? And if it's positive, it becomes what on the other side? Negative. And you're going to see a button on your calculator that says this, tan -1. See that? It's above yours. So if it's above yours, you have to press the second function key. You'll see second on your calculator like that. For those of you on the iPhone, it's in the top left corner. It says second. If you hit that, where that tan button was, it now says tan -1. You see that? So if I hit 0.5774 tan -1, I'm going to get a degrees of that angle being 30 degrees. Tell me if you get that on your calculator. Got it? Okay, let's see. I'll show you. Keep going. So you got to hit the second thing in the corner. No, hit that first. Yeah. So keep going with what you're doing. Boom, you got 30, right? Got it? Okay, so type the number, point, and then hit 10. -1. Boom. Oh, you're in radian. Hit degree. Yeah. Try it again now. 10 -1. I'll help you 1 second. 5. 10 -1. Boom. Got it. 30. You see, you got it? 30, you get it? Good. You get it? Got it? You get it? Boom. There we go. 30. Whew. We worked through it. Trust me, the more you go through this, the easier it gets. So the next one, what do we got to do to this tan? Yeah, we got to move it over, right? Because we want the angle E by itself, and this becomes tan -1. So then if we did that on our calculator, what'd you get? Sorry, 1 sec. So if we round that to the nearest degree, it's what? 15 degrees. And then our next one here, we have tan H, and we move that over to become tan -1. Now we're cruising. 16, is that what we both got? 60, 60. Boom. Now we're grooving, right? We're starting to understand. So yeah, it was a long way. We got it. Now we can find, basically, ladies and gents, if we have a right angle triangle and I want to figure out what this angle is, and I have the opposite side length and I have the adjacent side length, I can find out what that angle measure is. That's the whole point of doing this. And then we're eventually going to get to a point where we might have the degree and we want to figure out what that is. That's the whole point. Okay? We're going to be able to figure out all the measures of a right angle triangle based on those cool new buttons that we're going to take a peek at. Okay?